Hello friends, welcome back to our channel Adami Education. Today is going to be the third and the final part of the paper solving of Physics 2026 paper of class 10. Let's begin with the fifth question. An object is placed in front of a convex lens and it forms an image of the same size on a screen. Moving the object 12 cm close to the lens results in the formation of a real image which is 3 times the size of the object. Calculate the focal length of the lens. So in this question we have two cases. In the first case, the object, when it is placed in front of the convex lens, it forms the image having the same size. So from here we can understand that the object was placed on 2f. As a result, the image is also formed on 2f and it is also of the same size. Now if you are moving the object 12 cm closer to the lens, we get a real image once again, which is 3 times the size of the object. That means in this case the object is between f and 2f. That's why the image is larger in size. So let's solve it using the two different cases. So case 1. So as you can observe in the question, no value has been given for the object distance and the image distance. So we are just going to assume that the object distance is u and the image distance is v in the first case. So we know the formula for magnification, it is v by u. Since the image formed in the first case is formed on a screen, that means it is a real image which is inverted in nature. Thus the magnification will be -1. The minus only represents that the image is inverted, not erect. -1 is equal to v by u. That means you can say that u is equal to -v. This is the relationship between the object distance and the image distance. Now we know from the lens formula 1 by f is equal to 1 by v minus 1 by u. Let's put the values. 1 by f is equal to 1 by v minus v. So if I solve it, I am going to get the value of the focal length as v by 2. Okay. Now in the next part of the question, they have said that the object is being moved 12 cm closer to the lens. So now let's consider case number 2. In case 2, let us consider the object distance is u dash and the image distance is v dash. Now again, using the formula of magnification, it has been said that the image formed is thrice the size of the object. That means the magnification will be -3. Again, the minus sign represents that the image is formed in the inverted manner, or the image is a real image. So v dash by u dash. Yeah. So now instead of u dash, we can write u dash as u plus 12, because it has been said that the object is moved 12 cm closer to the lens. So the new object distance becomes the old object distance plus 12. So now if I solve it, -3u minus 36 is equal to v dash. Now from the previous relationship we know that u is equal to -v. So I can also write it as 3v. 3v minus 36 is equal to v dash. This is the expression for the image distance in the second case. Okay. Now let's use the formula of lens in order to find out the relationship between the focal lengths. We know 1 by f is equal to 1 by v minus 1 by u. What is 1 by v? Over here it is v dash and u dash. So instead of writing v dash, I can write it as 3v minus 36. And instead of u dash, from here, from this expression, let's see, u dash will be equal to v dash by -3, isn't it? So instead of u dash, we can write it as -3 by v dash. Now let's solve it. So instead of writing the value of v dash, let me again write it as v dash only. It will make it easier for me to solve. So 1 by v dash plus 3 by v dash is equal to 1 by f. I hope it is clear. Let me just, 1 by v dash plus 3 by v dash is equal to 1 by f. So if you solve it, you are going to get 4 by v dash is equal to 1 by f. Now let's relate the previous value which we got and the value of v dash which we have got in this second case. So we are going to equate them and we are going to find the expression for the focal length. Let me do it somewhere here. So 1 by f, we got it as 4 by v dash. Now from the previous case we saw that from the previous case we saw that F was equal to V by 2. So what will be 1 by F? We can write it as 2 by V. And from the case number 2 we saw that V dash was equal to 3V minus 36. So instead of V dash, let's write 3V minus 36. So now in the expression all the values are in terms of V. Let's find out the value of V, and from there we are going to find out the focal length. 6V minus 72 is equal to 4V. So 2V is equal to 72 and V is 36. Okay, so now if V is 36, we have seen in the first case that F is equal to V by 2. So what will be the expression for F? F is equal to V by 2, that is 36 by 2. So the answer would be 18 centimeter. So I guess this was the question that they had asked. Yes, you have to calculate the focal length of the lens, and hence we have found it out. So in questions where none of the values of the object distance and the image distance are given, you need to use the relationships of the various parameters that you have learned, and then you can easily solve the question. Hope you have understood this question. Let's move on to the next one. Atmospheric temperature after a hailstorm is greater than the temperature during the hailstorm. You have to say whether it is true or false. So first of all, this is a very common observation. You all must have observed it, that after a hailstorm ends, the weather around, or the temperature around, becomes quite cool and calm. So why does this happen? You have studied about this in the chapter calorimetry, that the hailstorm, which is actually ice, when it falls, in order to melt, it has to take some heat from the surrounding in order to melt. So if it is taking heat from the surroundings will automatically get cooler, the temperature will drop. So the answer for this question will be false. And also do mention the reason for it. So what will be the reason? Let me just repeat it once again. During hailstorm, the ice which is falling on the surface, in order to melt, it will take some heat from the surrounding. And since the heat is taken from the surrounding, the temperature of the surrounding will slowly decrease. As a result, the temperature around us will become cooler. Which thermal physical quantity of a frying pan changes by making its base heavier? So you must have observed this nicely in your kitchen, that in frying pans generally what happens, the base is made thicker. So what is the reason? It is in order to increase the heat capacity of the material. So if the heat capacity of the material is more, what will happen? It will be able to absorb the heat quickly, and as a result your food will be cooked quickly. So the correct answer will be increasing the heat capacity. The next question is a very easy one, directly from the book. State the principle of calorimetry. It has been given very nicely in your book, so you are just going to repeat it. And since it is a principle, you have to write exactly as it is. Don't change any word. So let me just dictate it for you. The principle of calorimetry states that when a hot body is coming in contact with a cold body, heat is lost by the hot body and heat is absorbed by the cold body, and this process will happen as long as both of them acquire the same temperature, and the amount of heat lost by the hot body will be equal to amount of heat gained by the cold body. This is what you use when you are doing the numerical. So this is the principle of calorimetry. So this was a very easy set. Next question. The given graph shows the cooling curve of a liquid. State the freezing temperature of the liquid. Name the phase change happening in the region QR, and in which state, solid or liquid, does the above substance liberate heat at a faster rate. Justify. So this is a cooling curve. That means the object is now cooled from a temperature of 50 degrees Celsius to 0 degrees Celsius, and the time required for the entire process to occur is 35 seconds. Okay. So the first question was, what is the freezing point of this freezing temperature of this liquid? As you can see, in the region QR, the phase is changing. That means the object is changing from one state to another. So since it is the cooling curve of a liquid, I can say that initially it was at a temperature of 50 degrees Celsius. Then the liquid reached a temperature of 20 degrees Celsius. Then, as we can observe in the region QR, the temperature is not changing, but the time is moving. That means in this phase what is happening? Some state change or phase change is occurring. So we know that whenever a liquid is freezing, the definition of freezing point is that the temperature at which the liquid freezes into the solid state without any change in temperature. So in this part of the question of the curve QR, there is no change in temperature. So obviously this is my freezing point or the freezing temperature. So 20 degrees Celsius will be the answer. Now the next question is, name the phase change happening in QR. Like we have already discussed, what is happening? The liquid is freezing into the solid form. So the correct phase change will be freezing. In which state, solid or liquid, does the above substance liberate heat at a faster rate? So what is happening? See, in this phase PQ and in this phase QRS, we have to see in which of the phases the object is releasing the heat at a faster rate. This means the temperature is changing but with a very short time duration. So in the region PQ, it is a liquid, right? And in the region what is this? RS, yes. In the region RS, it is a solid now. So as you can see, in order to convert, so as you can see in the diagram, the time required during the liquid phase for changing the heat is 20 seconds. But in the solid state, it is only 5 seconds. So obviously, in the solid state, it will liberate or it will release heat at a faster rate. So this is the answer. Again, a very direct and a very simple question. Hopefully, you have understood. Next, moving on to question number 6. The diagram below shows a wheel with a handle. Two forces F1 and F2 of equal magnitudes are acting on the handle as shown in the diagram. Which force will produce the negative moment? As you know, whenever the force which is applied on a body for rotational motion rotates the object in the clockwise direction, then the moment is taken to be negative. So if the motion of the object is in the clockwise direction, then the moment will be negative. And if it is in the anti-clockwise direction, the moment will be positive. So let's see which of the forces will produce a clockwise motion. So if I consider F2, force F2 is in this particular direction, so it is going to rotate the wheel in this direction, isn't it? And force F1 is in this particular direction, so it is going to rotate the wheel in this direction, clockwise direction. So obviously the correct answer will be F1. Since F1 is the force which is producing the motion of the wheel in the clockwise direction, the moment produced will be negative in nature. Now the next question is the wheel in equilibrium? Yes or no? And you have to justify the answer. So let me tell you the answer of both the questions in one go. We know one thing, that an object will be in equilibrium in case of rotational motion if the clockwise moment is equal to the anti-clockwise moment. Now as you can see that the forces both are equal in magnitude, but is their distance from the center equal? As you can see, the force F2 is at a distance of r from the center, but the force F1 is at a larger distance, r plus some small value, this much. So of course the perpendicular distances from the center of rotation are not equal. So obviously the object is not in equilibrium. I hope you will be able to write it in this manner. Next question. Name the unit of work done used in subatomic scale. Again, a very easy question. We have studied this directly in the chapter number 2. So when we talk about the work done or the energy in the subatomic level for electrons, protons, atoms, etc., the unit which we use is electron volt. Okay. To which class of lever does a pair of scissors belong? This is also again a very easy question. You can just imagine the structure of a scissor and easily understand. In a scissor, the fulcrum is at the center, the load is at one end and the effort is on the other end. The load is the paper or the thing that you are cutting, that is the load, and the effort is the handle on which you are applying the force, and at the center where the handle and the blades are connected, that is the fulcrum. So we know fulcrum is at the center for a class 1 lever. So the correct answer will be class 1 lever. A stone is tied to a string and displaced from A to B, okay, by the application of a constant force F in 3 different ways as shown in the diagram below. Arrange the 3 cases in ascending order of the work done by the force. It has been given that AJB is a semicircle in the first case and AB is equal to 20 centimeter. Okay, so this is again a very interesting question. So see this question very nicely. We know the formula of work is Fs cos theta. Okay, and what is this cos theta? The angle between the force and the displacement. So in the first case, as we can see, let me write it as work 1, Fs. Now what is the value of theta in the first question? Theta is the angle between the force and the displacement. So when the displacement is in this direction, the force is in this direction, the force and the displacement are perpendicular to each other because the object is moving in a semicircle. And even though the object moves in a circle or a semicircle, the displacement will always be perpendicular to the force, and the force over here would be the centripetal force. So cos 90 degree, theta is 90 degree, cos 90 is 0, so the work done will be 0. Hope you have understood. Now in the next part, in work 2, as you can see, the direction of force is this and the direction of displacement is also the same. So what is the angle between the force and the displacement? 0 degree. So Fs cos 0 degree, that is Fs. This is work number 2. Now if we consider work number 3, again Fs cos theta. Now what is the angle? It has not been given, but it has also been said that theta is less than 90 degree. So if theta is less than 90 degree, if you remember the standard angle values of cos, you know the value of cos is a decreasing function. That means the initial value of cos, that is cos 0, will be 1, and when it goes towards 90 degree, it will slowly decrease. So if the value of theta is less than 90 degree, which obviously means that the work done in this case will be less than the work done in the second case. So if I arrange it, what will be, they have asked, we have to arrange it in the ascending order. The smallest work done will be in case number W1, then we have W3, and then we have W2. Hopefully you have understood the question. Again, a very good conceptual question. Next one, a ball of mass 20 gram falls from a height 45 meter. It rebounds from the ground to a height 40 meter. So what do you mean by this thing rebounding? You know, whenever an elastic substance, or imagine a ping pong ball, when it falls on the ground, it again jumps back, right? So this procedure is called rebounding. Okay, you're going to see this term again and again in class 11 if you take up science. So we have to find the initial potential energy of the ball, the speed at which the ball hits the ground, and the loss of kinetic energy on hitting the ground. A very easy question once again. Let's see. So the initial potential energy, you know the formula of potential energy is mgh. So the mass of the ball was 20 grams, so we'll convert it into kg. The acceleration due to gravity has to be taken as 10. If it is not mentioned also, you can take it as 10, not an issue. And the height, initially they have said the initial potential energy, so the initial height was 45 meter, yeah, so 45. So let's solve it. The correct answer will be 9 joule. This is the initial potential energy of the ball. Now the next question is, you have to find the speed at which the ball hits the ground. Now we know very well, due to the process of conservation of energy, what is going to happen. The potential energy at the maximum height, that is the initial potential energy, will be equal to the kinetic energy of the body when it just hits the ground. So I can say that the kinetic energy of the body will be equal to 9 joule. Yes. So what is the formula of kinetic energy? Half mv square. This should be equal to 9. So let's find the value of v. Half, the mass is again 20 v square equals to 9. So v square is equal to 900. So v will be equal to 30 meter per second. This is the velocity with which the ball is going to hit the ground. Now the next question is, what will be the loss of kinetic energy on hitting the ground? So initially there was some kinetic energy. After it will hit the ground and it will rebound again, the kinetic energy will obviously change. So what will be the loss in kinetic energy, or what will be the change in kinetic energy? So let me just erase this first, then let's solve. Yeah, so what will be the final kinetic energy? Since now it has gone up to a different height, the final kinetic energy can be written as mgh2, again due to the process of law of conservation of energy. So mass is 20 by 1000 into 10. What is the new height now? 40 meter. So the correct answer is 8 joule. So the initial kinetic energy was 9 joule and the final kinetic energy is 8 joule. So what is the loss in kinetic energy? 1 joule, right? So a very easy question, isn't it? You can easily get 3 marks for solving this question. So if your concepts are clear, your idea about conservation of energy is very clear, these questions are going to be very easy for you to solve. Let's move on to the next one. To lift a load of 30 kgf, Suhas uses a single fixed pulley while Radha uses a single movable pulley. The displacement of efforts in both the cases are equal. In an ideal situation, calculate the ratio of efforts in both the cases, the potential energy gained by the load in the two cases, and you have to also find the efficiency in both the cases. So let's see the first one. We know the mechanical advantage for a single fixed pulley is 1, and the mechanical advantage for a single movable pulley it is 2. And we know that the formula for mechanical advantage is load by effort. So load by effort in the first case is equal to 1, and it has been said that the load for both of them is 30 kgf. So 30 by E is equal to 1. So what is the effort in the first case? 30 kgf. Let's find the effort in the second case. In the second case, the effort is going to be 30 divided by 2, that is 15 kgf. So this is the effort in both the cases. So if you remember the mechanical advantage of the two kinds of pulleys, you can easily solve this question. Now the next question is, you have to find the potential energy gained by the load in both the cases. So let's see. Let me just erase it first. Achha, we had to find the ratio in the first case, isn't it? So the answer would have been 30:15, that is 2:1. Yeah. Now the potential energy, we know the formula of potential energy is mgh. We have just done the question. So mg is the weight or the load, right? So load into the height will give you the potential energy. So fixed pulley is the first case, yes. In case of fixed pulley, what happens? The displacement of the load will be equal to the displacement of the effort. That means the distance by which the effort will be applied, the same distance will be moved by the load. But in case of a single movable pulley, what happens? The load rises by half of the distance. The load rises by half of the distance as compared to the distance moved by the effort. So in the question it has been said that the efforts are moving the same distance. So obviously the load will move different distances, right? This is a fact. Now we are going to use this concept and we are going to find out the ratio of potential energy. So in case of the fixed pulley, since the load is same, I am not writing the value, I am just writing it as L. The height moved in the first case will be dl. In the second case, the height will be dl by 2. So what will be the ratio? The ratio is 2:1. Now in the next question, we have to find the efficiency. Since they are talking about an ideal machine, in an ideal condition, we know all the machines have an efficiency of 100%. So in this case, both the pulleys will have efficiency 100. So the ratio will be 1:1. So the correct answers are 2:1, 2:1 and 1:1. Hopefully you have understood the question. Let's move on to the next question. One end of a plastic foot ruler is held tightly at the edge of a table and the other end is plugged. Name the vibrations produced in the ruler. So this is also a very easy question. It is a direct example from your book. Now, since you are applying some force on the ruler and then it is vibrating on its own, it will be known as natural vibrations. Although in reality, what will happen after a while, it will stop vibrating. It will convert into damped vibration. But if I consider the case that there is no resistive force around it and on plucking once the object is vibrating on its own, the answer will be natural vibrations. Okay. Now the ruler is pushed inside partially and plugged again from its free end. State with a reason whether the frequency of the vibration increases or decreases. Now what happens? We have pushed the ruler further inside, and now obviously imagine this was the length of the ruler which we plugged initially, and now since the ruler has been pushed inside, let's imagine the length of the ruler which was free to vibrate has decreased. So what will happen to the frequency? Since the length is decreasing, right, there is a smaller vibrating length, obviously the frequency will be more. More the length, less will be the frequency, and vice versa. So in order to increase the frequency, the length has to decrease. This is what is happening in the question. So the frequency will increase, and in the first case it will be natural vibrations. Okay, let's move on to the third question of question 7. Two persons A and B are standing in front of a cliff in the same line 170 meters apart as shown in the diagram. Okay. Person B fires the gun and hears the echo in 3 seconds. Then the person A standing in front of the person B fires the gun. Speed of the sound in air is 340 meter per second. Very easy question. You have to find the distance of person B from the cliff. So this is person B. Let me write it a little larger, and this is person A. It has been said that the distance between the two people is 170 meters. The cliff, the distance between the persons and the cliff has not been given. The speed of sound is given. Okay, so we know the formula. Speed is equal to 2d by t. This is the case in this is the formula in case of an echo. So the speed of sound is given as 340. 2 into d. What is the time after which the person B is hearing the echo? 3 seconds. So what will be the value of d? D is going to be 510 meters. Simple calculation. The minimum time in which B hears the gunshot fired by A. Okay, so look at this very carefully. B has to hear the gunshot which is fired by A. Now, A is firing the gunshot like this. The sound is going there. Then again the sound is coming back, and B has to hear the sound. So how much distance we are going to take? We are just going to take the distance 170 meter. And no, this is not the case of an echo, because we have to just cover the distance 170 meter. B is hearing the echo, right? But the distance which the sound has to travel in order to reach B is only this much. There is no bouncing back in this case. So the formula for this will be slightly different. S is equal to d by t, not 2d by t. Because B is not hearing his own gunshot. B is hearing the gunshot of A, and the gunshot sound of A has to travel only 170 meter distance in order to reach B. So the speed again 340, distance is 170 by time. So if you solve it, you are going to get 2. So t is equal to 0.5 seconds. Hopefully you have understood. Now the next question is, the echo is softer than the original sound due to the decrease in what? Again, very obvious, we have studied this previously, that frequency of a sound will never change. Only what can change? The amplitude. So the echo is generally softer as compared to the original sound because the amplitude will be less. The energy goes on decreasing, isn't it, as we continue the echo. So these are the answers. Let's move on to the next question, question number 8. Bulb A rated 160 watt 40 volt and bulb B rated 40 watt 40 volt are connected in the diagram. We have to calculate the ratio V1 is to V2. Okay, let's see. Let's first of all write what are the ratings of the bulb. So for bulb A, the rating is 160 watt 40 volt, and for bulb B it is 40 watt 40 volt. So let us find the resistance of each of the bulbs. We know the formula of resistance is V square by P. So this is resistance 1, V square 40 square by 160. On solving it, we are going to get 10 ohm. And what is R2? Again, V square by P. On solving the values, we are going to get 40 ohm. So the resistance of the second bulb is 40 ohm, and for the first bulb it is 10 ohm. Now we know the formula V equals to IR. In this case, since the bulbs are connected in series with one another, obviously the current is same. So if the current is same, the voltage is only dependent upon the resistance. So we can say that the ratio of voltages will be equal to the ratio of the resistances. So let's put the values. 10 by 40, that is 1:4. This is the required ratio. Now the next question, if the bulb A fuses, the current in the circuit remains the same. Is it true or false? So what will happen if the bulb A fuses? That means this bulb is not there in the circuit anymore. The bulb has completely lost the connection. So obviously what will happen to the current? Will there be any current flowing in the circuit? There will be no current because the circuit is going to be an open circuit. So obviously the value of current will not remain same. The current will become 0. Next question. The reverse side of a 3-pin plug with incorrect correction of wires is shown in the diagram. So for this you have to remember the color coding of the various wires which are used. So red wire is given, green wire is given, and blue wire is given, and this is the reverse side or the back side of a 3-pin plug. So you have to find what is the fault in the connection. So it's very obvious and easily understandable. This wire is always for the earth wire, the earth pin, which is the thickest one. Now we know for earth pin the color coding is either green or it is brown, but over here it has been given red wire. Red wire is used for live wire. So the green wire should go here and the red wire should come here. These two changes need to be done in order to make the circuit correct. Mention a risk factor involved if the user operates the appliance without correcting it. Obviously, what will happen? The person will get an electric shock because the connections are wrong. The appliance will become live. The first connection will be the live wire connection, not the earth wire connection. So, obviously, there are high chances that the person will suffer from an electric shock. Will the appliance function in the present condition? Obviously not, because the earth wire is connected in the live end and vice versa. So obviously there will be no functioning of the appliance. Next question. In the combination of resistors shown below, you have to calculate the resistance across AB when the switch S is open, and the resistance AB, again the resistance across AB when the switch S is closed. So let's consider both the cases and let's make the diagram for it. When the switch is open, that means this is not existing. Okay, this is not present. So what will happen? These two are in series. Again, these two are in series. So let me find out the resistances. R1 is 12 plus 6, that is 18 ohm, and R2, that is the bottom part, it is again 6 plus 12, which is 18 ohm. Now the combination is in parallel. These are gone, and now the entire thing is in parallel. So 1 by R is equal to 1 by 18 plus 1 by 18, that is 2 by 18. R will be equal to 9 ohm. This is the first case. Now when the switch is present, in that case what will happen? This is a closed connection. So these two are in parallel, and then they will be in series. So if we solve it, 1 by R1, this is the left side, 1 by 12 plus 1 by 6. R1 is equal to 4 ohm. Similarly, R2 will be 4 ohm, because obviously again 6 and 12 is under consideration. So the overall resistance now will be the sum total of this, that is 8 ohm. Hopefully you have understood. A very easy question, but you have to understand in which case which of the resistors are in series and which of them are in parallel. That's the only thing that you have to remember. Next question. An electric iron rated 1100 watt and 2020 volt is operated for 5 hours. You have to calculate the minimum rating of the fuse required. Then you have to find the energy consumed in kilowatt hour and the cost of energy consumed if the rate is rupees 10 per unit. Very easy, once again, directly from the book. Now you have to find the minimum rating of the fuse required. That means you have to find the current rating of the fuse. We know the formula, P is equal to VI. Let's just put the values. 1100 equals to 220 into I. On solving it, you are going to get the value as 5 ampere. This is the minimum rating of the fuse which you need to attach to the circuit. The energy consumed in kilowatt hour. We know the formula of energy is power into time. The power is given in watt, so let's convert it into kilowatt directly, and the time is in hours only, so it's fine. So let's solve it. 5.5 kilowatt hour, very easy. And now you have to find the energy consumed if the rate is 10 rupees per unit. You know per unit means 1 kilowatt hour. So if for 1 kilowatt hour the cost is rupees 10, for 5.5 kilowatt hour the cost will be 5.5 into 10, that is 55 rupees. Very easy question. Next one. When a magnet as shown in the diagram is moved towards a coil at a speed of 5 meters per second, the galvanometer shows a certain deflection to the right. How will the direction and magnitude of the deflection change when the coil also moves with a speed of 5 meters per second in the direction of motion of the magnet? So both the magnet and the coil are moving with the same speed. So what is going to happen? So if both of them are moving in the same direction and that too with the same speed, so will it create any change? Will it create any change in the magnetic field? Of course not. Both of them are moving with the same velocity, so it is cancelling it out. So there will be no deflection. When is the deflection occurring? When the magnetic flux linked with the coil will change, and for that either we can move the magnet or we can move the coil. But if both of them are moving in the same direction with the same velocity, obviously there will be no such change in the magnetic flux, so no deflection. In the opposite direction of motion of the magnet. So now the magnet is moving in this direction and the coil is moving in this direction. They are moving in the opposite direction. So what is happening to the velocity? We are summing up the velocity. The total velocity of the system will be the sum total of their velocities, since they are moving in the opposite direction now. So the deflection will remain same. The deflection will not change. The deflection will remain in the same direction, but the amount of deflection will increase because both of them are moving with a larger velocity. Okay, I guess you have studied about this in maths, that when two objects are moving in the same direction with some given velocities, the overall velocity or the sum total of their velocity is actually equal to the subtraction of the relative velocity is equal to the subtraction of the velocities. And if the two objects are moving in the opposite direction, then in order to find the overall velocity we have to add it up. So in the first case we subtracted the two velocities, resulting in zero velocity, so no deflection. In the next case we had to add the velocities. Since the velocity was more, the deflection will be more, but the direction of deflection is not changing. In order to change the direction of deflection, we have to either change the direction of the motion of the magnet, or we have to change the motion of the coil along with the magnet. In order to change the direction of deflection, we have to change the motion of the magnet. That means now the magnet has to move in this particular direction. Okay, I guess it is clear. Next question. Which element is used in the lining of special aprons worn by workers in nuclear power plants? Very easy. Lead. Lead is used in gloves, it is used in aprons because it will prevent the radiation from being absorbed by the person. So this is the reason also. Let me again tell it. Lead is preferred because it is a dense metal, use these terms, and it will absorb the harmful radiation. It will prevent the harmful radiation from reaching the human being. Okay, so this is the reason we use lead. Also, while disposing of radioactive wastes, we have studied that they are sealed in lead containers. Again, the same reason. Sodium 1124 emits a nuclear radiation which does not alter the mass number, but it is deflected by the magnetic field. Name the type of nuclear radiation emitted by the atom, and write the equation for this radioactive decay. We know that in an alpha particle, when an alpha particle is emitted, the mass number will decrease by 4 and the atomic number will decrease by 2. But when a beta particle is emitted, what will happen? There is no change in the mass number, but the atomic number will be increasing by 1. And in case of a gamma particle, there will be no change. So obviously, in this case, the mass number is not altered, but also the magnetic field deflection is shown. That means it is a beta particle. So let me write the equation for this. Sodium 1124, it releases a beta particle. So what will happen? The atomic number will increase by 1, okay, and the mass number will remain same. So that's all for the session. Hopefully you have understood the entire question paper of 2026 physics. It was not very difficult. Obviously some of the questions were a bit tricky, concept based, understanding based, but I won't say that it was very difficult or it was not at all doable. So for me, I believe that if you practice more and more questions, you're obviously going to get the confidence in order to face any kind of question which is asked to you in the examination hall. So first of all, focus on confidence building and concept building, and for that you need to be very thorough with the syllabus. Go through each and every point in the book properly and practice as many questions as you can. Tomorrow we are going to start with chemistry. Hopefully you will enjoy the session as well. Bye bye, have a great day ahead and keep studying well.